The purpose of this video is to showcase the on-track train simulation software written during spring 2008 at Pitt for the software engineering class. This software is responsible for managing, creating, routing, and dispatching trains on a track circuit. It was developed over the past 15 weeks. So let's get started. So as you see, whenever we initially open up, we have the option to choose a track file. So we're going to do that here. The track file is in the format of a CSV, which shows the various connections between blocks and the information contained on each block. Once we select that track, we have the option to select more tracks, but for the purpose of this demonstration, we're just going to use the green line. So once we select our track, the main menu opens. Initially, we have the option to open the central traffic control, track controller, and track model. Once trains have been instantiated, we will also have the option to view the train model and the train controller. So we're going to start with the track model. As you can see here in the track model window, we can select our track from the drop-down. And we see that the fields are populated with the information from the first block in this block list. So right off the bat, we can see that we have the ability to toggle failures, including rail failure, power failure, and a track circuit failure, that we can select from this drop-down. So we can see that when we select those and hit the toggle button, these failure status lights become active, and the selected block is added to the closed block list. And again, when we hit toggle again, the lights are no longer selected, and the block is removed from the closed block list. Additionally, we can select various blocks and see that the information contained in these fields changes. We also have the ability to open up beacons contained on blocks, which are denoted by the green status light next to the beacon label. And we can open that up by clicking either on the status light itself or on the label. And here we can see some information about this beacon, the distance to the station name, and some other information regarding that station. As well, we can see station information. So here we'll select L73. Again, we can see that it is a station by the lit up status light next to the text here. And again, we can click on this text and see some information about the station, including the name, the temperature, the passengers waiting there, and then the total passengers that exit there. Again, there are no passengers that have exited because no trains are running on this circuit. So next, we'll go to the track controller. You can see here in the track controller window that a lot of the functionality contained in this module is regarding the blocks and block maintenance. So there are 9 different track controllers around the track. Each control their own contained section of blocks, as you can see from this block drop-down. The type of line is also shown here in the header. And then we have 3 status symbols here in the middle for the lights on a switch, the lights on a crossing, and then the status of a switch and the connected blocks. Down here in the bottom section is the section for block maintenance. Here we can see that whenever the track controller is in automatic mode, these options are disabled, as the PLC logic will take care of it. But when we switch to manual, we can see that we now have access to some of these options. And then the Import PLC button is what allows us to actually import our PLC logic that will be controlling the track controllers. So now we'll go to the central traffic control. The central traffic control, or CTC, is what is responsible for creating, queuing, and dispatching trains, as well as controlling the system clock and doing some track maintenance. So we can see up in the header that we have access to the system clock, The scheduling section is below, and then track maintenance is to the left. So we'll start with track maintenance. We select our track from the drop-down, and we see that we have access to all of the blocks on that track. Additionally, we can see that the track state is reflected by two status lights, one for the status of that block, whether it's been closed or not, and whether it's occupied by a train. Additionally, we have a switch state, which will become active if the selected block is a switch, and that will reflect the state of that block. So we'll first demonstrate closing a block. The clock needs to be started for this. We select close block from the drop-down and press the submit button. We can see that the status immediately goes red here. This is also reflected in the track controller. Go to green 8, block 1, and we can see that the status is also red on this track controller. Additionally, if we want to repair the block and restore the status of this particular block, we can select repair block and submit. You can see that the status immediately goes green, and that is reflected on this track controller as well. The next thing we're going to show is a switch. So we'll go to block 13, and we can see that the switch state lights up, denoting the particular status of this switch. We can go to toggle switch here, submit, and we see that the status toggles. This can also be seen in our track controller again, and we can see that the corresponding switch state is the same as our switch state in the CTC. And whenever we toggle it again, we can see that the switch state is also reflected in the track controller. So now we're going to go through the process of creating, queuing, and dispatching a train. This is the main functionality of the CTC and really the program in general. So we begin by selecting a track from our drop-down. You can see that the track image populates the lower left-hand corner of the application. And then we have the option to add a train name, which we'll do now. A departure time, which doesn't matter because we'll be manually dispatching this train during this run. So we'll just enter some 1s here. And then the final authority in the form of a block, or in this case, the yard, meaning that the train will complete one entire circuit of the track and then return to the yard. Now additionally, we have the option to select stops at stations on the track and set particular dwell times or how long the train will remain at that station. We can do this manually, or we can import a schedule, which is what we'll be doing for this particular example. So we click our import schedule button, and again our file chooser pops up. Go to our CTC here, and we'll select our schedule. Again, this is just a CSV file in a particular format, which is outlined in the instruction manual. Click open, and we can see that our table is populated by the various stops and their respective dwell times. So now we're ready to add our train to the queue. We click the Add Train button, and we can see that the train has been added to the queue, and its schedule is reflected in this bottom table, although now we have a estimated time column that describes the estimated time to each of these stops in minutes. Now whenever we're ready to dispatch the train, we just need to click the dispatch button. But for now that we have created a train, we can go back to our main menu and see that every option is available. So we'll start off here by showing the train controller. As you can see, you can select it from the drop-down on the right. We'll open it up here, and we have the window for the train controller. Now there's not much to see here while the train isn't running, but as you can see, we have the option to change the mode from automatic to manual, in which case we can set the speed manually. While in automatic mode, the speed is controlled by the CTC, and ultimately the track controller. In this central section, we can see the current speed of the train, the set speed, and the authority. The authority is a byte of information that reflects the next stop of the train. In this case, because the train is at the station, the service brake is on. In the center here, we can see the current or last station that the train visited. We can see our power command with configurable KP and KI values. We can see our status of brakes, the track circuit itself, and the train engine. And then our last section here involves various peripherals like lights, doors, and temperature. We'll come back to the train controller more once the train is dispatched. Now we can look at the train model. Again, we can select it from the drop down on the right. We'll open this up and we can see here that similar to the track model, we can simulate various failures. So here we'll select an engine failure from our list and click Start. And we can see that now the train is emulating an engine failure. And to end that, we just click our End button. And this can be done for any or all of our various types of failures. The main purpose of the train model is just to display the information about the physical train itself, as well as give the user the option to pull an emergency brake, which will halt the train immediately. Additionally, we show some ads down here in the bottom of the window that will shift every minute or so. This ad will also be responsible for telling the passengers when the last stop is and that they must exit the train at that last stop. So now we'll come back to the CTC here, and we're actually going to dispatch our train. So we click our dispatch button, and we see the train appear here in the right-hand table. The green denotes the movement status of the train. It is green when it is moving, it is red when it is halted or at a station, and this status is also reflected in this small status light in the bottom right-hand corner. So as of right now, our clock speed is normal wall time. It's rather slow, so we'll keep it at this current time for the time being, although we do have the option to add a multiplier to speed things up. But for now, we're going to go back to the train controller, and here we can see the current speed is growing. We have our power command providing the power to the train's engine, and we have our set speed, which is the current speed limit on the track. Additionally, we can see that the authority has shifted and that the train is now being told to stop at the next station. If we open our train model, we can also see this information reflected here, the current speed, the power, and then some other information such as the temperature and other non-static information. So we'll come back to the CTC here, and we have several options of what we want to do. We'll speed up the clock for now, and we'll see that once the train hits 73 here, that it stops at that particular station. It will be stopping for 1 minute. We can see that this is reflected in the track model by the occupied light here, as well as the occupied list that shows both the head of the train and any blocks that are still occupied by the tail of the train. So our train continues on its way after stopping at that station. Again, if we go back to our train model, we can see that the train now has 18 passengers, which are randomly generated at each station. We can also see the passengers reflected in the CTC in the right-hand column. Now, if we want to send a new speed to the train, we have that ability from the central traffic control. So let's do that now. As you can see, the train has stopped at the next stop, is denoted by the red highlight of the row. So for the next stop, we're going to send it a new suggested speed of 20 miles per hour. We can see this new speed reflected in the speed column. However, this speed will be overwritten once the train enters a block with a new speed limit. So while this train waits at this station, let's open up our train controller and just confirm that there is a 0 mile/hour speed, and if you caught that, the set speed was actually 20 before it reverted back to its speed limit of the next block. So here we're coming into our next station. We can see that the current speed once again shifts down to 0. Our set speed remains, and our authority shifts to stop at the next station. Once we've stopped, our authority now just tells the train to continue moving until it receives new authority. That is the sun power command. And we can see that the last station is now reflected in the train controller here. So we're going to speed this clock up a little bit just to move things along. It has the option to go up to 10 times the wall speed. We can see that at that last stop, more passengers were added. We're up to 91 passengers now. And we're moving our way around the track. We make our way to our last stop, and the final authority shifts to the yard. And once the train starts moving again, that's where it's going to be heading. Again, we can open up our track model and see the occupied block shifting as the train traverses the track. And if we want, we can even select a block and see for a brief moment that that block becomes occupied, which we can see here with C7. So now the train's making its final way around the last loop. And it will soon be headed back to the yard. And we can see here that the train comes into the yard and then is deleted and disappears from our dispatch table. So we'll change our clock multiplier back down to 1. And then now we're going to show some other features that can affect the train while it traverses the track. It should also be noted here that we can see our throughput over the course of the train's runtime. So we're going to create a new train called another, and this time we're going to give it a departure time. So right now it's 21, 13, 26. We'll actually have this get dispatched at 15 here. We're going to add some stops here. We'll add Dormont, and we'll give it a dwell time of 30 seconds. We can see that if we try to add train now, that we need more than one stop, as passengers need a place to get off. So we'll add our second stop, Overbrook, for another 30 seconds. And we'll add this train to our queue. Once again, we can see the train information is reflected by the train controller and the train model. And we'll speed up our clock here. And we're going to see that the train automatically is dispatched whenever its departure time is reached by the clock. So the train dispatches whenever it reaches 21:15. Let's turn this multiplier back down. And now we can show some of the braking features of the train. So we're going to open up the train controller. We're going to change into manual mode. And we're going to turn the emergency brake on. As you can see, the speed immediately falls and the train halts on the track. Now if we turn the emergency brake back on, we can see that the speed begins to grow and the train continues to move on the track. Now we can also affect this from the train model. If we open up that window, we can select the emergency brake here. And once again, you can see the current speed of the train falling to 0 and its position halting on the track. we click it again, the train begins to accelerate once again towards its set speed. We'll switch back into automatic mode for the train controller here. And now we can demonstrate a change in authority while the train is moving on the track. So even though the train's next authority is dormant, we can set a new authority that is either before or after. We'll wait until after, let some more passengers get on here. Let's speed up our multiplier. And once we come to L73, the train slows down and stops at dormant. We'll wait for our passengers to get on here, and then the train continues on its way. Now if we want to set a new authority, say at O, we can select that from this list of blocks and then click the Set Authority button. Now let's turn our multiplier back up, and we should see the train stop at O87. It should be noted that even though the new authority has been set, this is not reflected in the table as there is still another stop on the route. But if there were no more stops, then this authority would be reflected by the selected authority from the drop-down list. So we can see ourselves approaching O87, and the train comes to a halt, and we can see this reflected in the train controller and the train model. Whenever we're ready to continue on our way, we can select a new authority. Let's give it a block later on the track, say W, and we'll give it an authority of W 123. We set our new authority, and the train continues on its way. We'll speed up our multiplier here to move things along. We should see the train stopping at Overbrook before moving on to its new authority at W. The train is approaching its next stop now, and we see it stop at W 123, which actually happens to be Overbrook, in addition to that being a stop on the schedule. So let's set another authority just to really drill this point home. We'll set this in C here. Set our authority, and again, let's set a new suggested speed of 30 miles per hour. And because we're moving through the blocks so quickly, that suggested speed is immediately overwritten by the speed limit of the block. So here we'll see our train coming around to C8, and it says stopped, which is reflected again by the red hue. So now let's give our train authority to finally re-enter the yard. We set our authority, train status goes to green, and the train continues on its way. See again that once the train reaches the yard, it is deleted and removed from the dispatch table. So that about does it. It shows all of the features of our application. We had a lot of fun writing it up, and we hope you had a lot of fun checking it out.